Hello folks, this is your 2023 February March session, paper 1-2, and the question number is 14. It is concerned with the chapter forces, density and pressure. It says a probe is used to monitor the quality of water in the sea. Probe is the probe. The probe is suspended by a vertical string, which is attached to a sphere. The stationary sphere floats in equilibrium on the surface of the sea, so it is able to float here. The sphere has a weight of 5.00 Newton. The probe and string have a combined weight of 2.0 Newton. So that means the total weight here will be, total weight of all these things will be equal to 5.00 plus 2.00, and that's equal to 7.00 Newtons. The density of the seawater is 1.03 into 10 to the power 3 kg per meter cube. So rho of water is equal to 1.03 into 10 to the power 3 kg per meter cube. The upthrust acting on the probe and the thread is negligible. So this thing is negligible because they have assumed that this volume is too small. They don't displace much water, so that's upthrust is negligible. What is the volume of the sphere below the surface of the sea? So we have to find the volume of the surface below the surface of the sphere below the surface of the sea. So this much is below the surface. This much is below the surface. Now, since this body is floating, what we should have is the force of upthrust felt by this sphere. This sphere should be equal to the weight, total weight. Now, the force of upthrust is equal to, so we have this force of upthrust is equal to weight of water displaced. Force of upthrust is always equal to the weight of water displaced. This is the principle of flotation, and that's equal to mass of water displaced into z, weight equal to mg. So this gives us, it is a rho of water into volume of water displaced into this z, and this equal to rho w, volume of water displaced, is equal to volume of the immersed portion. Volume of water displaced is equal to the volume of the immersed portion. It's because the volume is like that. Volume is the space taken. The initial volume, the space of water was taken by this sphere. So that's why this is equal to volume of immersed portion of the sphere into this g. So now we must have, so I use this value over here. So I must have rho w vis z is equal to w, which means I have got this vis is equal to w by rho w into z. So or this vis is equal to, the weight total is 7.00, then rho w is 1.03 into 10 to the power 3 into z is 9.81. So it will give me so it is 7.00 divided 1.03 exponent 3 into 9.81, like this. Yes, so it becomes 6.92774 into 10 to the powers minus 4 meter cube. So when rounded off, it becomes 6.93 into 10 to the power minus 4 meter cube. Now going through the answer choices, choice number D reflects it, but all others are incorrect choices.